Okay, how are we all doing, folks? Today we're going to look at density. So our main equation for density is that density is equal to mass per unit volume. So mass divided by volume. Okay, and you're already good at kind of seeing that one in the book. So now if we look at our question here, this is question 4 on page 312 in the knowledge and understanding part of it. All right, we don't know what's the density of a block of wood where the volume is 200 centimeters cubed and the mass is 180 grams. Now, before we dive into this one, we're just going to take a little moment and think about units, okay? Because units is often where this can get kind of messy. The SI units of density are kilograms per meter cubed, okay? We can write them like that. You can write them kilograms m to the minus 3. All right. Don't worry too much about that one for the moment. However, these numbers are really big sometimes, or really small, because they're huge units. So what we often use is grams per centimeter cubed. Okay. You can also write this as grams centimeters to the minus 3. All right. So for the moment, we are going to stick with these guys. It just means nicer numbers. We're looking in tens and hundreds and rather than thousands or anything like that. So those are our units. So let's come back over here. The mass is, in this case, 180 grams. The volume is 200 centimeters cubed. So the density equals the mass over the volume, m over v. All right. That equals 180 over 200, and that is going to equal 0.9. But if you're ever unsure about this one, you can always use your calculator to check these things. 180 divided by 200, that equals 9 over 10, or 0.9. Okay, 0.9. Don't forget your units, grams per centimeter cubed. All right, that's our answer right there. So once we lay it out nice and steady with this equation, it all falls into place fairly nicely. Now let's try a slightly trickier one. So we just remind ourselves of our density equation. Density equals mass over volume. Now sometimes we can write these things in symbols to save us writing out all those letters. So that's the symbol for density. It's rho, it's a Greek letter, it's like a P in italics, equals m over v. Now that is a little bit neater. For today, because we're getting used to it, I'm going to stick with the letters. But if you're comfortable with what all these symbols mean, you can switch over to that, no problem at all. Okay, so in this case, using the densities given in 1a, the mass of a gold bar, length 300 by 10 by 8 centimeters. Okay, so first of all, the value is given in 1a. So the density of gold is, and we'll have a look at that, 19.3 grams per centimeter cubed. Gold is one of the most dense metals, knocking around. Okay, and we want to know its mass. So if we take this equation here, we need to rearrange this a little bit so we have mass on one side. And what we're going to do is we're going to multiply both sides by volume. All right, so it's got to end up being the mass equals the density multiplied by the volume. All right, it's like I brought the volume back up over this side, or if you prefer to think of it as multiplying by volume on both sides. All right, that's our equation there. Okay, I have my density, but I haven't got my volume yet. So let's just come over here for a second. Volume. Now, got to be careful of units. We're in grams per centimeters cubed here, so we're going to stay in centimeters over this side. And that's nice because they've given it to us in centimeters. So it's 30 by 8 by 10. Okay, so length by the height by the width, calculating volume just like you do in maths, and that is going to be equal to 2,400 centimeters cubed. Okay, now I have my volume. Back to here. So the mass is 19.3 by 2,400, and that equals, check it out here, 19.3 by 2,400 And a nice big number here, 46,320. 46,320 what? Okay, well, we are working in grams and centimeters cubed, and we're looking for mass, so that is going to be grams. Okay, you can actually include the units in the calculation, but for this stuff you normally don't need to. Now we just make that a little bit neater, so that is 46.32 kilograms. So a bar of gold, which is probably about the same weight that you are. Now we'll go over to our final piece here. Okay, so this is question 5, just put a little line there. Question 5 part B. And what volume would lead have if we knew the mass? So this is just moving the whole equation around another way again. So in this case we want to know the volume. We have the density. So density of lead is, if we look back up in the question, you'll see again it's pretty dense. Remember the lead we had in school? Imagine that gold is about 50% denser than that again. Okay, we have the mass, and that's given to us in our question. If we go back here, it's 56 grams, so a really small bit of it. So what volume is it? Well, it's going to be pretty small, I suspect. So we take this equation, rearrange it. Volume is going to go up there, and density is down below. So we say the volume is the mass divided by the density. Alright, so all we're really doing is taking that one basic equation and rearranging. Sorry about the screaming, young Bateses are going wild these days. So let's put our mass in. So again, we're in grams per centimeters cubed. Okay, 56 over 11.3, and that equals, back to calculator time. Clear. 56 divided by 11.3. And again, there we go, 4.96, I'm going to round to 2 decimal places. 4.96 what? Well, I'm in centimeters, so that's centimeters cubed. So 4.96 centimeters cubed is quite a small little bit of lead, which is what we'd expect. And there we have it. Have a nice weekend, guys.